Hi, my name is Ramasu, and welcome to my presentation on question 7 from the 2008 BGCSE Science Double Award Paper 2. The question says the diagram shows the electronic structures of an atom of calcium and an atom of oxygen. Part A1 says I used the diagrams to write the electronic configuration or the electronic arrangement of a calcium atom. Well, a calcium atom has the first shell, second, third, and fourth. So the calcium atom has 4 shells, and the first shell has 2 electrons. Let's put a 2 there. The second shell has 2, 4, 6, 8 electrons. The third one also has 8 electrons, and the last one has 2 electrons. Last one has 2 electrons there. So that's 2, 8, 8, 2. Okay. So part 2 says draw dot and cross diagrams to show the bonding in calcium oxide. Well, calcium oxide is an ionic compound. It's ionic compound. This means that it is formed by a negative ion and a positive ion. Right. So it means that the particles in the compound are charged, but they have opposite charges, right? So what happens is that let me show you a periodic table. So we have calcium here and oxygen on this. Well, calcium is in group 2. This is a group. The rows, the columns represent groups, and the rows represent periods. So calcium is in group 2 and period 4, or the 4th period. Oxygen is in group 6 and on the second period. Now both oxygen and calcium they want to be in group 8, right? They want their last cell to have 8 electrons. Now we saw from the diagram here that the last cell in calcium has 2 electrons, and the last cell in oxygen has 6 electrons, right? So for the last cell in calcium to have 8 electrons, calcium has to lose these 2 electrons, and oxygen has to gain electrons. So then these 2 electrons, they move from calcium to oxygen, right? So when calcium loses 2 electrons, it goes to the 3rd period, because the 4th period will now be empty. It moves to the 3rd period, where now it has 8 electrons in the 3rd shell, right? And oxygen gains 2 electrons from calcium, and then it moves to group 8 because it will have 2 electrons in its outer shell. Right? 2 electrons in its outer shell. Having 8 electrons in the outer shell makes oxygen and calcium stable. So all these elements in this group here, in group 8, they're stable. They're called the noble gases. because they have 8 electrons in their outer shell. So all the other elements want to be like them. All the other elements want to have 8 electrons in their outer shell, right? So when calcium loses these 2 electrons, it becomes positively charged. It gains a charge of a positive 2. And when oxygen gains these 2 electrons, it has a charge of -2, right? So let's draw the dot and cross diagram to show the bonding in calcium oxide. So we have calcium here. Which are the 2 inner electrons. So you have 1, 2, and 3, right? So this is for calcium. Now this is too big. I'm gonna post the video and draw the atoms. Okay, so I have drawn the cells for calcium and oxygen. Now let's put in the electrons. 2, 4, 6, 8. 2, 4, 6, and 8. Now for oxygen, let's make bolts. 2. Then we have 1, 2, and 1, 2, 1, 2. Then we have 2 crosses here. Why? Because these 2 electrons were taken from calcium, right? They were gained from calcium. So we could put a label here, say Ca, then O for oxygen. Then we have to write the charges on the. This has a charge of 2 plus, and this has a charge of 2 minus. And then we ideally we should write. What we do next is that we write the electronic configuration. Ideally we should write it at the base here, but there's no space, so I'm gonna write it on the side. So then the electronic configuration for calcium is 2,8,8, right? And for oxygen is 2,8, right? So you can see that calcium has lost these 2 electrons. They've been gained by oxygen, and oxygen now has 8 electrons in the outer shell. So you could also label this as calcium ion, and this one is an oxide ion, right? So let's move on to part B. Part B says give 2 physical properties of compounds with the same type of bonding as calcium oxide. The 2 physical properties of ionic compounds are that they have high melting and boiling temperatures. Right. The other one could be that they conduct electricity when in molten or solution form. This means that if you dissolve ionic compounds in water, they will conduct electricity. Or if you melt organic compounds, then they will conduct electricity. But they can't conduct electricity when they are solid. So when they are solids like this, they cannot conduct electricity. So let's move on to part C. Part C says state whether calcium oxide is basic, neutral, acidic, or amphoteric. Well, calcium oxide is basic. Why? Because most metal compounds or most metal oxides are basic, right? Yeah, most metal oxides are basic, or you could also say that calcium oxide reacts with acids to form water and a salt, right? So let's move on to part D. Part D is I should mention that most non-metal oxides are acidic. Most non-metal oxides are acidic. For example, calcium oxide. I mean, carbon dioxide when dissolved in water is acidic. Sulfur dioxide when dissolved in water becomes acidic too. D says calcium oxide is formed in the blast furnace during the extraction of iron. Describe how calcium oxide is formed in the blast furnace. Well, in the blast furnace, there's calcium carbonate. So calcium carbonate is heated to high temperatures. And it breaks down. It breaks down to form carbon dioxide and calcium oxide. Here's the equation. It's calcium carbonate. You heat it and then it forms calcium oxide and carbon dioxide. Right. Part 2 says what happens to the calcium oxide in the blast furnace. The answer is that it reacts with silicon dioxide or hot sand. It reacts with hot sand or silicon dioxide to form slag. Okay, so that's the end of the video. My name is Ramasu. You can find me on Facebook, or you can follow my Facebook page, GCSE tutorial videos. Thank you for watching and see you in the next video.